Okay, I'm going to do a quick recap of a little bit before we go on to talk about more about carrier proteins. Okay, so we talked about how there are 3 ways to get through a plasma membrane. And I'm just going to go back to the note really quick to show you. We talked about channel proteins that can be electrically charged. If not, it can dissolve into the membrane, and also carrier protein. Then we went on to talk about the plasma protein. Now, I'm going to go on about carrier proteins today. Okay. We'll put it as continued since we did mention it before. Okay, so carrier proteins are taken across, they're used to go across the plasma membrane by mediated transport. And 3 conditions must be met before a carrier protein can take a molecule across the plasma membrane, okay? And these are important. You need to know these 3 conditions. Okay. One is specificity. Okay. This is carrier proteins are made for a specifically shaped molecule. It's the example that I gave before of a key fitting into a lock. The main basis of this is it has to fit. If the molecule does not fit into the carrier protein cannot carry it, okay? The second condition is competition. So what does this mean? Similarly shaped molecules compete for the same carrier protein. Okay. The molecule with a higher concentration will be more competitive. Okay, I'm going to give an example of this. Now, think about M&Ms and Skittles, okay? I know the Skittles might be a little bit bigger, but let's just pretend they are both similar size, okay? At least they're the same shape, okay? So the Skittles and the M&M represent the molecules, and they're trying to compete for the carrier protein to take them across the plasma membrane. Now, let's compare the carrier protein as the taxi, okay? Both of them are competing with the taxi that who's going to take them into the plasma protein. Now, let's say you have 100 Skittles and only 65 M&Ms. This is just an example, just to make you understand this concept. If you have 100 Skittles, that's the higher concentration molecule because it's 100 of Skittles, 65 M&Ms. So who do you think is going to grab the taxi, or AKA the mediated transport, which is a carrier protein? It's going to be the Skittles, okay? And that's how competition works. Now, the third condition is saturation. So what does this mean? Saturation means when it's filled up, it's done, okay? No more molecules can get in. It's just like the taxi, again. You fit as many as you can in there, and maybe it might turn into a clown car, but after a certain point, there's nothing more that's gonna fit inside the taxi. That's how the carrier protein works, okay? So saturation means when it's filled up, it's over. No more molecules can come in. Okay. Now we're going to talk a little bit about membrane transport. Now this is important because we're going to talk about this also. Everything you're building on in module 1 and 2, you're going to carry it on throughout the rest of the year. So if you know these chapters well, you can always come back to it. It'll make you understand other chapters better. If you don't understand this chapter, well, it's going to be hard to move forward and understand the concepts later on. So I would suggest that you study well, especially for chapter 1 test, just so you know it well. Now, membrane transport, we're going to basically talk about passive and active transport, okay? So let's talk about passive transport first. Okay, so there are 2 types of passive transport. One is diffusion, okay? And the second one is facilitated diffusion. Okay, so before we get even further into this, I want to clarify a few things. Now, let's talk about passive. When we talk about passive, what does that mean? It means, basically it means it's passive because it does not require cellular energy. What is cellular energy? ATP, okay? Everything we do throughout the whole year is going to come back to where is the energy for that reaction or that process coming from. Basically the mitochondria. Mitochondria is a powerhouse of the cell. It produces ATP as the energy. So passive transport means it does not require cellular energy, okay? That's why it's called passive. Now, the 2 types of passive transport is diffusion, facilitated diffusion. Now let's talk about diffusion. Okay, now, diffusion is movement of ions or molecules from a higher concentration to a lower concentration. Okay, now let's talk about an example. Okay, I'm going to give you a science, biology kind of an example, and I'm going to give you a practical one that you can remember. Now, an example is sodium. Na stands for sodium, okay, that's a sodium, and K stands for potassium. You will need to know this because we will talk about this throughout the year. So if you haven't taken chemistry, this is something to know. This stands for sodium, this stands for potassium, okay? Now, generally, more of sodium is found outside the cell. So it's greater, this is the greater sign, outside the cell. Okay, and potassium mainly is found greater in greater quantities, this is the greater sign again, inside the cell. That doesn't mean this is not found outside. This does not mean it's not found inside. It is, but it's greater, this is a greater quantity outside, and potassium is a greater quantity inside the cell, okay? Now, remember we talked about channel proteins in that picture. See, this is a channel protein, that big green glob. Okay, see that tunnel that goes through it? That's a channel protein. Now, what happens here? The sodium and this potassium exchange, and they diffuse in and out based on the charge of the channel protein, okay? Okay. Now, that's the biology example. Now, in real life, think about this. You know the timer you get with the game boards, like the hourglass with the sand coming through it? Now think about that. That's the perfect example of diffusion, okay? It is coming, the powder you see is coming from a higher concentration, which is the top, and it's going into an area where there's no powder, right? So that's the area of lower concentration. So as that's a perfect example of how diffusion works, okay? Now, the second thing we're going to talk about is facilitated diffusion. Now, this is when diffusion occurs with mediated transport. What does mediated mean? Mediated means that it's helped. The transportation is helped. Sorry, it's diffusion. It's an O. So mediated transport means something is helping it diffuse across. Okay, and what do you need with mediated transport? You need a protein carrier. So when diffusion occurs with mediated transport with a protein carrier. Okay, so what is special about this as well? Well, actually both of them does not need ATP. Okay, and the other thing you need to know about diffusion and facilitated facilitated diffusion is that these occur naturally. Okay, now we're going to talk about active transport. Okay. Now, what makes it active? Passive, we said it does not require cellular energy. What does active need? It requires cellular energy. And the cellular energy is ATP. Okay. Now, why does active transport need cellular energy? And why is it that it needs active transport? One of the reasons is because the molecules are larger, okay? So basically larger molecules require this. Okay. So this will go, it goes against the gradient. Okay. Now, let's talk about an example. Now, sodium goes into the cell when potassium comes out. Remember we said there's more sodium outside the cell? Now, once the sodium is inside the cell, it's going to require a carrier and ATP to push it back outside the cell again. Okay? So it'll diffuse in, but it has to be pushed out by active transport. So it goes in by diffusion, comes out by active transport. Okay. Now, this whole process is known as something called endocytosis. We'll talk about more about this later too. So this is a process by which large molecules are taken into a cell. Okay. Now, there are two ways this can occur. Actually, kind of three. But we're going to talk about endocytosis and exocytosis. I'll just put this here just as a place marker so we know. But let's talk about two things under endocytosis. Let's talk about pinocytosis. Okay. And phagocytosis. And you'll need to know both of these. So, pinocytosis is basically cell drinking. And phagocytosis is basically cell eating. So if you look in page 29 in your textbook, okay, and you look at figure 1.12 and 1.13, it'll help understand a little bit more of this. Okay, so what happens, pinocytosis is cell drinking. And what is that basically? It is basically a process that allows proteins to enter into the cell. This is known as cell drinking also. Okay, so why is that? Because the proteins dissolved, they then become dissolved into the fluid around the cell. Okay? Now that whole process you'll see in that figure. If you look at that picture, you'll understand it a little bit better. Now, phagocytosis means cell eating. Okay? Now, what's the difference? So this pinocytosis ingests fluids with cells in it. Oh, sorry, fluids with proteins in it. Okay. Phagocytosis is different because it eats it. It actually ingests the particles, okay, rather than the fluids. Ingests particles rather than fluids. That's why it's eating. Okay. Now, phagocytosis is an example, okay, of of WBCs. WBCs are white blood cells. Okay. What do WBCs do? WBCs eat up bacteria and viral particles and foreign cells to get rid of it so that it does not cause our body to have infections. Okay? Okay. So that's how our body fights infection. Now, let's talk about exocytosis, okay? So, endo means inside, okay? This is how it goes inside the cell. So you're saying how particles are taken into the cell. Exocytosis means what? Think of exo means exit. That means it's taking it out of the cell. We can see this color. Same thing. It's a little darker. Okay, so this transports material from inside to the outside. Okay. Now, this is also called secretion, okay? And you'll need to know this because we'll talk about secretion a lot in the coming chapters. And this secretion, we talked about the picture earlier, secretion is done where in the cell? It's done in the Golgi apparatus. You can go back and review the notes to see how that connects. Now, if you want to see an example of exocytosis, look at page 30, figure 1.14 in your textbook, okay? You should look at the textbook pictures because it'll help you understand this better, okay? Also, so this is the end of Module 1, and we'll be having a test after this. I don't like to give you a test on a Wednesday because you only have one day to study for it. So I'm going to say this will be for Monday, and I will be sending a text regarding how you had to pick up your texts. Your tests from school. That being said, I would like you to complete. This will help you study for the test as well. Page 22 and 23 in the coloring book. You will need to color and label the pictures. And the picture looks like this, just so you know, so that in case you have a different edition, it's basically cells, tissues, and integument. Okay.